This is PreCalc assignment 20, let's see, 2024, Slant Asymptotes. It's going to be example 7, okay, and page 174, chapter 2. Okay, Slant Asymptotes is considered a rational function whose denominator is of degree 1 or greater. If the degree of the numerator is exactly 1 more than the degree of the denominator, then the graph of the function has a slant. It's called oblique asymptotes. We learned asymptotes horizontal, and if denominator is bigger than exponents of denominator is bigger than numerator, it's going to be horizontal asymptote y equals 0. If it's exponents of the numerator, leading exponents of the numerator, as same as leading exponents of denominator, it's going to be the ratio of the leading exponents coefficients. So I hope you remember that. And also, if there is one more scenario, if it's, what if numerator is big, right? If its numerator is big, it's there is no horizontal asymptotes, okay? And we also did the vertical asymptotes. Vertical asymptotes is a number on the numerator. If you plug in, it's going to be canceled out to 0. That's undefined. So in this case, they give you the example. This is, you will see example of the there's horizontal, there's no horizontal asymptotes because exponents of the numerator is bigger, leading exponents of the denominator is bigger. Okay, so however, you could see vertical asymptotes because if you plug in -1, it's going to cancel out to 0. So you cannot plug in to negative x equal -1, which is, it comes down right here, x equal -1. That's the vertical asymptotes. Now, if the degree is 1 degree higher, if this is x here, x squared here, there is no horizontal asymptotes. However, there is a thing called oblique or slant asymptotes, which is, first you deal with the long division. So x squared minus 2 divided by x plus 1. So you do this equation with long division. So x comes here, x times x squared times 1x, right? You subtract negative x minus x is negative 2x. And you divide by this number again. So negative 2 goes here. X times negative 2 is negative 2x. 1 times negative 2 is negative 2. You subtract. If you subtract, they cancel out here. Minus negative 2 is positive 2. So 2 is a remainder. So this is a remainder. So the quotient is x minus 2. X minus 2 is right here. X minus 2 plus remainder is 2 over x plus 1. Now, what I highlight here, x minus 2 is a line here. That is a line called slant asymptote. See, the asymptote, definition of asymptote is a graph would never touch. So vertical asymptotes, this line, it would never touch. It will approaching infinity here. It approaching negative infinity here. And this line, it will close to this line, but it will never touch. That's the definition of asymptotes. I hope you understand. So let's do example 7. This is examples of 7. Sketch of the graph of f of x equal f of x equal x squared minus x minus 2 divided by x minus 1. So I do the long division here. X minus 1. So it's divided by x minus 1. So x goes here. So x times x squared minus x. So if you subtract those from this to this, there's no remainder but negative 2. It's constant. So this is going to be the remainder. So answer is, the quotient is actually for this division is x plus -2 over x minus 1. So let's write down here. This I wrote down here. Now, the rule I had is this number here, right here. Actually, this is the equation. So you have to write down y equal x. So this is going to be the oblique or slant asymptotes right here. So this red one is oblique asymptotes. Now, I wrote down this little table here. So negative infinity approaching to not x equal 0, actually x equal 1 approaching. So this is might be a graph right here and approaching like this. We don't know, it could be right here, it could be right here. It might be symmetrical over the intersect, right? So I wrote down here negative infinity approaching 1, and this is the number maybe I can think of it. If you plug in -2, what will happen? So if you plug in -2, let me write down. -2 is going to be +4. So I should write down 4 minus my -2 is going to be you add 2 and -2. So this one cancels. So it's going to be 4 here. But you plug in -2 here, right? So 4 over -3. So I put the negative outside. 4 over -3. So if you plug in -2, -4 over -3, so it's like a 1.3. So -1.3, so it's right here. So if I see dots here, points right here, so it must be goes through this way. And this one go approach to this one, close to this line, and goes to this way. And approaching to infinity, very close to green dotted line, vertical asymptote. All right, so the other interval is +1 to infinity. So I choose 3. So 1, 2, 3. If you plug in 3, what happens? So let me erase this. So 3 times 3 is 9, minus 3, minus 2. 3 minus 3 minus 2 is 4. Okay? And where should I write down? 4 here. 4 over, if you plug in 3 here, 3 minus 2 is 2. So 4 over 2 is 2. That's why I wrote down 3 over 2. I don't know what this 2 is from. So I erase this. So 3 and 2. So let me see. 3 and 2. 3, 1, 2, 3, and 2. It's going here, right here. Okay, see? So this line is approaching this way, and it's looks like symmetry over this dot, this point. So it goes to go this way. I don't want to touch this, so I just finish here, and this one goes this way. Okay, so it goes to approaching negative infinity, and this one approach positive infinity. Okay, I hope you understand. This is slant asymptotes. Let's see. Okay, it's exactly the same way. I hope you understand. So music for today. If you have any question, please stop at my office hour. And let's see what I can play. Have a nice break.